It would take between 1,000 and 81,000 years for a spacecraft to reach Alpha Centauri if we used conventional propulsion. Plus, astronauts would have to deal with the countless risks of the mostly unexplored interstellar medium. But there might be a way out of this seemingly hopeless situation. Gram-scale spacecraft that rely on lasers when it comes to traveling through space. One of such concepts is called the swarming Proxima Centauri, and it has recently been chosen for the NASA Innovative Advanced Concepts program. You see, traveling through interstellar space is a question of speed, energy, and distance. Proxima Centauri sits 4.25 light-years away from the solar system. That's 25 trillion miles, which is incredibly far away. For comparison, the farthest distance ever traveled by a spacecraft is 15 billion miles from Earth. Voyager 1 has been moving in outer space for more than 46 years, reaching a maximum speed of over 38 miles per hour. Traveling at the speeds that we can allow at the moment will make interstellar transit exceptionally long and totally impractical. And don't forget about the energy requirements such a journey would demand. Anything other than a tiny spacecraft weighing a few grams doesn't look feasible. But the solution might have been found. Bouncing photons off of a laser sail could solve the speed problem. But since a single photon doesn't have much momentum, a lot of them are needed. And since even in a couple of decades we probably won't have a lot of power available, the thrust will be weak. That's why the mass of the probes has to be minuscule. Not tons, but grams. The proposal suggests using a 100-gigawatt laser beamer, boosting thousands of tiny space probes with laser sails to a speed of 10 to 20% of the speed of light. This mission concept might be ready for development around mid-century. Then, the probes could reach Proxima Centauri as early as 2075. The researchers involved in the project have already demonstrated how a fleet of 1,000 spacecraft could deal with the difficulties of interstellar travel while maintaining communications with Earth. At the same time, the 8-year round-trip time lag caused by interstellar distances and general relativity makes it impossible to control the swarm of the probes from our planet. That's why the fleet must possess a great degree of autonomy when it comes to navigation and deciding what data should be delivered to Earth. One more issue is the cost of such a mission. The greatest expense will be the laser array, while the tiny probes might be reasonably cheap to produce. The scientists believe that their project can be developed with a budget of $100 billion. It's not so much compared to the usefulness of such a mission, which is likely to be astronomical. How come? Red dwarf Proxima Centauri, which is a member of the Alpha Centauri star system, has an Earth-like planet orbiting it, Proxima Centauri B. It's the closest exoplanet to Earth. Its mass is similar to that of our planet, and it travels in the habitable zone of its parent star, which means there might be water in this world as well as an atmosphere rich with oxygen. This planet might harbor life, or it could be a dry rock. In any case, it's a promising target in the search for alien life. Unfortunately, we can't detect the planet's biosignatures because our usual methods for detecting them don't work with Proxima Centauri B. Most exoplanets are discovered and explored through the transit method, where a planet regularly passes in front of its parent star, and we see a recurring dip in the star's brightness. That's how we know that the planet is there. But Proxima Centauri B isn't a transiting planet. It was discovered by a different method. When we look at the light coming from Proxima Centauri, we can notice that the gravitational pull of Proxima Centauri B makes the star wobble a bit. That's how astronomers found out that the planet was there. They also managed to estimate its size and mass. But no one can figure out much more than that. Hopefully, a swarm of tiny space probes will help us solve this mystery.
It seems you've been lost in the dark, cold vastness of space for ages. You don't remember what green trees look like. You can recall what fresh morning air smells like. You're about to run out of what little fuel you still have. And then, you see it! A planet! Can it be Earth? Your battered spaceship is moving closer to the planet, and a giant wave of bitter disappointment almost drowns you. This alien world looks nothing like your beautiful blue planet. You get down to work. After thorough research, you realize that the planet in front of your eyes can't be anything else but Kepler 22b, which, in turn, means that you're 635 light-years away from home and are unlikely to ever return to Earth. You need some time to get used to this horrible revelation. When you come back to your senses, you understand that you have to do everything in your power to survive, even if it means living in an unfamiliar, probably hostile world. The only good news in that ocean of desperation is that Kepler 22b is located in the habitable zone of its star, and it means there might be liquid water on its surface. And where there's water, there's also the possibility of life. Your life. Earth's astronomers discovered this exoplanet, which is what all the planets outside the solar system are called, using the transit method. The problem with many exoplanets is that it's hard to spot them since the bright glare of their stars keeps them hidden from our telescopes. But the transit method means that instead of looking for planets, scientists watch the star, Kepler 22. They noticed that over time, its brightness changed. That was because Kepler 22b regularly blocked the star's light. This discovery also helped researchers figure out the size of the planet and the way it orbited its star. It turned out that the planet was 36 times more massive than our planet. If you decide to settle down in this world, this information will probably make you feel even lonelier. Your new home is also 15% nearer to its star than our planet is to the sun. If Earth moved over so close to our star, everything and everyone on the planet would become fried in no time. Consider yourself lucky that the star that is now illuminating your spaceship, lying sideways on the surface of the planet, is smaller and colder than the sun. It means you'll get as much sunlight as you would if you were on Earth. The temperature on your new home planet is quite comfortable, around 60 to 72 degrees F. But don't get your hopes up. You don't know for sure yet, but there's a theory that the planet is rotating on its side, like Uranus in our solar system. What can it mean for you? Unfortunately, nothing good. Even though the position of the planet probably seems insignificant, the complications might be fatal. The problem is that in this case, the north and south poles of Kepler 22b would be either plunged into darkness or illuminated by super bright sunlight for half a year. Now, that wouldn't be a matter of being a daytime or nighttime person. It would mean that temperatures on the planet would change from freezing to boiling all the time, which wouldn't be great for your survival. Anyway, you haven't had enough time to figure out whether this prediction is true. What you have noticed, though, is that your new home is covered with an ocean. You almost dropped into it before resuming control over your spacecraft and landing it on the shore instead. According to your calculations, the ocean might be around 160 feet deep. It might also act as natural climate control, keeping the wild temperatures at bay by storing heat in the summer and releasing it during the winter. But even if it's true, your main concern is food and oxygen. You're running out of your scarce resources at an alarming speed. What are you going to eat on this lifeless planet? How will you get some air to breathe? Your future looks darker and darker with every passing minute. Will the sheer strength of your willpower help you survive? Time will tell.
You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo, there's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window.
We'll start with one of the most recent and shocking discoveries of 2020. Perhaps our solar system has life beyond Earth. This is Venus, the second planet from the Sun and the sister of our home planet. It's called so because it has a similar size and mass, but the conditions on it are simply terrible. The temperature on its surface reaches 890 degrees Fahrenheit because of the greenhouse effect, and the atmospheric pressure on it is as strong as if you were 3,000 feet underwater. But in this hostile world, there can actually be life. For many years, there have been discussions on this subject. In 2007, scientists discovered there once had been an ocean on Venus. That is, in the distant past, there could have been some form of life. But in the fall of 2020, there was an epic argument in which scientists tried to find out whether life on Venus exists right now. In September, the discovery of a new life marker on Venus was announced. The ALMA telescope in the Atacama Desert found phosphine gas above the planet, and the amount of this gas suggested that it may have been produced by certain microorganisms. But already in October, the data was analyzed again, and the new results indicate it was an error. So today, we consider Venus to be uninhabited once more. But who knows? Maybe soon we'll get new data, and new disputes will arise in scientific circles. And while some scientists are scratching their heads and still concentrating on Venus, others have looked into distant space and discovered 24 planets on which life can exist. And on all of them, living conditions are much better than on Earth. Such planets are called superhabitable. These superplanets must be 1.3 times larger than the Earth and twice as massive. Thus, they will have stronger gravity and, as a consequence, a denser and warmer atmosphere. So, the climate on superhabitable planets must be similar to the tropical climate on Earth. This will ensure the maximum diversity of living organisms. The host star of such a planet must be a red dwarf. They're much smaller than the Sun and not so bright, but their lifespan can reach 70 billion years. For comparison, the lifespan of the Sun is 7 times shorter, and it's already past half of it. Slow and steady wins the race. It will give enough time for potential life to develop and evolve. And here's a suitable planet for the title of superhabitable, Kepler 1649c. In 2020, it was named the most similar planet to Earth. It's only 6% larger than our homeworld. It orbits a red dwarf, a quarter the size of our Sun. The planet is in the habitable zone of the star and makes a complete circle around it in 19.5 days. The climate on Kepler remains a mystery. It's known to receive about 75% of the light we get from the Sun. So the temperature on its surface may be close to Earth's, but we still don't know the composition of the atmosphere and other necessary conditions for life to appear there. The next discovery is one of the most amazing spectacles ever seen by humanity. It's the collision of a star with a black hole. In September 2019, scientists began watching how, for 6 months, a Sun-like star was being spaghettified. Light from this event traveled 215 million light-years, and we saw a star about 860,000 miles wide slurped up by a black hole. This black disk is so heavy that it has incredibly strong gravity. Nothing can leave its gravitational field. And now we see a star slowly approaching it. First, the glowing light layers of the star begin to stretch towards the black hole. It looks as if the star is simply unrolling like a ball of thread. Then we see this hot plasma lingering at the edges of the black hole. And it may seem these particles are now orbiting it, but it's just an illusion. This ring of light is called the event horizon. The black hole curves not only space, but time as well. This close to it, time slows down. To the observer, it looks as if the light near the edge of the black disk has almost stopped. But in fact, it has long been absorbed by the dark abyss. When a black hole eats a certain amount of star material, it starts spitting it out. Powerful beams of energy are ejected at speeds of over 6,000 miles per second. This is the light that attracted scientists' attention. In the end, the black hole has completely absorbed about half of the star and spit out the other half into space. And even though we watched this process for only a couple of minutes, it was happening for 6 months. And here is one of the youngest planetary systems that humanity has ever observed, AU Microscopii. It's so young, there's still a disk around it from the debris this system was made of. But this time, we don't even hope to find life here. The host star of this exoplanet continually emits radiation flares that would wipe out any form of life from the planet's surface. The planet that orbits this dangerous star is called Mc-B, and it's just a newborn baby by astronomical standards. It's so close to its star that it makes a complete circle around it in 8.5 days. The age of this planet is only 12 million years, so at the time Mc-B was born, mastodons walked on the surface of our planet, and meadows and savannas were covering the Earth's face. So you and I can consider ourselves old-timers, because the age of the Earth is almost 4.5 billion years. The next discovery took place in early 2020, and it's very similar to a landscape from science fiction. It's a planet with 2 suns. Well, more precisely, it doesn't orbit around a single star, as we are used to in our solar system, but around a binary star system, TOI 1338. The first big star is like the Sun. The other is a red dwarf, which is 3 times smaller. These stars completely circle each other in a little over 14 days. The planet that orbits these stars is the size of Saturn, which is much larger than the Earth. Although the sunsets and sunrises there look incredibly beautiful, this planet is unlikely to be suitable for any form of life. It's outside the habitable zone of its host stars, so it probably doesn't have liquid water. Mysterious radio signals from outer space have also been received in 2020. We're talking about fast radio bursts. Scientists recorded such signals before, but recently they have managed to prove that they are repeated after a certain period of time. The new data have forced the scientists to come up with a very bold theory that their source may be a magnetar. A magnetar is a neutron star that is small and has a huge mass compared to ordinary stars like the Sun. But they have the strongest magnetic field in the entire universe. Their lifetime is very short though, only 1 million years. But what baffled scientists the most this year was discovering that the moon is rusting. Corrosion needs oxygen and water to take place, but the moon doesn't have its own atmosphere to have both. The main theory says the solar wind is to blame. It moves at great speed and scrapes oxygen from the upper layers of the Earth's atmosphere. The wind continues to carry oxygen molecules through space, and eventually they reach the surface of the moon and cause metal ore to rust. By the way, the signature red color of Mars was created because of the rust. For a long time, there was an atmosphere and water. In combination with iron on its surface, it triggered a long process of rusting, which has lasted since ancient times. Another stunning discovery was found on the surface of the moon with a stratospheric telescope. It's an aircraft that carries a telescope. The plane raises it to an altitude of 8 miles, and this allows it to have a picture quality comparable to that of space telescopes. And with the help of such an unusual observatory, scientists were able to find water on the surface of the moon. Water molecules were found in one of the largest craters on the visible side of the satellite, but the number of water molecules is still extremely small there. The Sahara Desert has about 100 times more water than the surface of the moon.
Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal.
If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen. For example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially.
The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus, totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw.
But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas.
So now, does it mean there's life on Venus? Well, not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet.
Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine.
Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again.
If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars.
If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither.
Life originated in water, or so we always heard. In reality, it could have begun in ice. We know that it all started more than 3 billion years ago with simple microbes, and it's been evolving ever since. However, there are many theories about how exactly it happened. Maybe not heat, but cold was the beginning of everything. Cells were the first tiny life forms, but before we had fully developed cells, there were simpler things that couldn't survive on their own. Certain important chemicals for life, like the mentioned amino acids, usually float in water in tiny amounts. First, they needed something to help them stay together without spreading all over the place. Otherwise, they would have gotten lost in the sea. And second, they needed to stick together in groups to form more complex things. Moreover, when they started to form in groups, they started the process of evolution. They chose the best molecules to do specific tasks and kicked out the faulty ones. Without this organization, the fastest replicators, or parasites, would have taken over. There were several ways they could organize themselves. 3 billion years ago, oceans were covered in ice. And it turned out that certain important chemicals for life, such as amino acids and nucleic acids, are more stable in colder temperatures. When water freezes, these chemicals that hang out in the oceans get packed together, making it easier for life to form. Or maybe what helped them were special spots called hydrothermal vents. Imagine the deepest, darkest parts of the ocean floor, where hot water shoots out from cracks in the Earth's crust. Life might have started right there, in these extreme conditions. These vents spew out important elements like carbon and hydrogen, which are crucial for life. As the superheated water travels through the Earth's crust, it picks up other important stuff like minerals. When it finally bursts out of the vents, it creates a kind of soup rich in chemicals. In the rocky crevices around these vents, all these molecules could have come together and sparked the first signs of life. The hot, mineral-rich environment acted like a kitchen to cook the first recipes ever for living things. Even today, these vents are home to vibrant ecosystems, showing that life can thrive in extreme conditions. Ancient stories also talk about life starting from clay. It turns out that this idea has a scientific basis too. Imagine tiny particles of clay, like little grains of sand, sticking together in a structured way. As they grow and get bigger, they keep their original shape intact. They form bigger areas and clumps. They become kind of like patches, clay clumps with tiny holes inside. Each patch may be exposed to different things in the environment, like different chemicals or substances. When these outside molecules go through the clay, they get trapped along the way. Once trapped, these molecules get organized in specific patterns within the clay. This process is compared to how our genes organize things. Just like genes tell our bodies how to arrange different parts, the clay patches organize molecules. This theory was created back in the 80s, although it was very controversial at the time. We need more investigation to figure out whether this is true or not. Ancient people could have been onto something when they said that we all started with Zeus's lightning. Life itself is a chemical reaction, and it needs energy. Without energy, nothing happens. Cells are the building blocks of life. You can picture these cells as tiny factories bustling with activity, constantly working to keep you alive. Just like every factory needs a power source to keep its machines running smoothly, they need energy to do their job. In the world of cells, that power source is something called ATP, which stands for adenosine triphosphate. It's an organic molecule. There are also some backup generators with fancy names like thioesters, acyl phosphates, and reduced ferredoxin. They basically work like extra boosts. When life first started, it needed energy to make complex stuff like proteins and DNA. Back then, this energy came from the environment. It could be light, heat, chemicals, or even lightning. That lightning might have kick-started life. Back in the 1950s, scientists did something called the Miller-Urey experiment. They zapped a mix of gases that mimicked Earth's early atmosphere with electric sparks. Suddenly, that caused amino acids and sugars, the basic stuff of life, to pop out. All living things share a special code called DNA, the genetic code. It's one of the oldest and most important things about life. And we think this code existed in the very first forms of life too. This code is quite tricky. It involves putting the right building blocks, amino acids, together in the right order. And there are special molecules called tRNA and mRNA that help with this process. The early version of this code was probably simpler than what we have now. It might have used shorter instructions like using just 2 letters instead of 3. Scientists are still figuring out how DNA first appeared at all. Some think it might have started alongside metabolism, where certain molecules helped put the right building blocks together. Now, they think that the secret to understanding how DNA and proteins are formed lies in looking at RNA. RNA is a versatile player, a molecule that can do some of the jobs of both DNA and proteins. In the past, it could have been the star before DNA and proteins took over. And even though they're the main players now, RNA still has important roles in living things. For example, it can switch genes on and off, controlling how cells behave. But then comes the next question. How did RNA come to be? Well, we need to look for even simpler origins. RNA are big and complicated molecules, but life could have begun with smaller ones bumping into each other and starting chemical reactions. These reactions might have happened inside tiny capsules that acted like cell membranes. Over time, they might have evolved into more complex ones that could do the job better. In other words, life could have started with a basic recipe and slowly added more ingredients. Every living thing is made of carbon. Carbon is an essential life block. It's the stuff that makes molecules, and they form cells, tissues, and organs. Earth was very different many years ago. There were no plants or trees, and the air was different too. Instead of the oxygen we breathe now, there were gases like hydrogen, nitrogen, hydrogen sulfide, and of course, carbon dioxide, which contained carbon. In this ancient world, life might have started in a way where organisms didn't eat other organisms for energy. Perhaps they made their own food from these simple chemicals. They could eat this carbon dioxide, kind of like plants do today, and this is where they receive their carbon from. We call this autotrophic origin. They think that certain metals like iron and nickel, along with minerals containing them, played a big role in this process. These metals and minerals acted like assistants, helping chemical reactions happen that were important for life to begin. They were found all over the Earth back then, especially in places where there wasn't much oxygen. And finally, we have a wild theory that life didn't start on Earth at all. It could have been brought to us from somewhere else. Rocks from Mars sometimes get blasted into space by big cosmic collisions. Some of these rocks have ended up on Earth, carrying tiny microbes with them. So maybe, while we search for life on Mars, it could have been the red planet that started our very own life. Or maybe it wasn't Mars. Others suggest that life might have hitched a ride on comets from other star systems, traveling through space until they landed here. But if life did come from somewhere else, it just raises more questions. For example, how did life start in space in the first place? This is why scientists are a bit skeptical about this idea, which is called panspermia. In any case, the origins of life are a huge mystery, and we'll need decades of research to figure out the full answer.
The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the TESS satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot, 4-inch-wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, The pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry him there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in. In the icy wilderness of Antarctica, there was a peculiar rock. Amidst the vast, smooth, and snowy landscape, it stood alone like a dark smudge. This rock had been there for ages, untouched except for occasional snowfall. Roberta Score, a lab manager at NASA's Johnson Space Center, had spent countless hours in Antarctica searching for rocks just like this one. Antarctica was an unexpected treasure trove for these discoveries. These rocks were easy to spot against the blindingly white ice. Why was it so important? Because it wasn't just any rock. It was a meteorite that had fallen from space thousands of years ago. Roberta's rock, known as ALH 84001, was initially unimpressive. However, it turned out to be extraordinary. It was a piece of Mars. The rock's chemical composition perfectly matched the surface of the red planet. Turns out, it had been blasted off Mars during a colossal collision millions of years ago. It was wandering through space before landing on Earth. There, it had remained undisturbed for a very long time. Scientists at Johnson Space Center carefully examined this Martian visitor. Years later, physicists made a remarkable announcement. This meteorite contained tiny structures that looked just like living organisms found on Earth. NASA immediately shared this discovery with the world. We found fossilized evidence of life on Mars. However, as other scientists got their hands on the rock and conducted further studies, they began to doubt it. Yes, it was a fascinating piece of rock, but Martian chemistry might create similar structures without life being involved. So, unfortunately, it wasn't conclusive evidence. But all this debate raised a very important question. Would we recognize extraterrestrial life if we saw it? There are more than 200 different definitions of life in scientific literature. So, what should we be looking for? To figure out what makes something alive, scientists have come up with 3 important things that living things must have. First, living things need to store information about themselves. This information tells them how to work and what they're like. It's a bit like having a set of instructions for how they function. Second, they need to be able to interact with their environment and create reactions. These reactions help them get energy, move around, and respond to changes or dangers. Lastly, they must be able to make copies of themselves, reproducing, and making other things that are just like them. This ability is a big part of what makes something alive. The famous physicist Erwin Schrödinger was one of the first people to figure this out. He said that storing, using, and passing on information is super important for life. It's like a cycle. Information helps create reactions, and some of those reactions let living things make copies of themselves. On Earth, we see this in action. We humans, for example, have DNA to store our information. It helps us with our evolution. Thanks to all this, we can adapt to our surroundings over time. Nature sees that some traits are helpful for survival, so they stick around, while others get left behind. In other words, a way to define life is by saying that it's subject to this process called Darwinian evolution. But how did it happen that things capable of evolution appeared? And when did the very first life emerge in our universe? To find out the answer, let's go to the very beginning of everything. The beginning was the Big Bang. Right after it, there were no stars or galaxies. The universe started as a mostly even and empty place, with just a tiny bit denser than the rest. After the first second or so, first protons, neutrons, and electrons, among other particles, appeared. And just about a couple of minutes later, these protons and neutrons came together to make stable atomic cores. Then, everything was a superhot soup of particles for about 380,000 years. It was way too hot to form anything dense. The universe needed some time to chill. After it calmed down a bit, it let electrons join these cores, forming neutral atoms for the first time. Finally, some comfy temperatures. If we were there, we wouldn't have needed the sun to keep us warm. That cosmic background radiation would have been enough. Could life appear at this point? Probably not. In those early moments after the Big Bang, the universe had only hydrogen, helium, a tiny bit of lithium, and almost none of the other elements life needs. Life, as we know, requires things like water and organic compounds. So it wasn't about the temperatures, it was about the ingredients. Now, everything had to form over time from these atoms. To create something like a planet, which is much denser than the universe on average, it needed a lot of time and gravitational squeezing. Gravity is the real hero of this story. It changed the universe completely. Even though it started slow, it kept going and got stronger. Regions that were a bit denser could pull in more matter, and the denser they got, the more they attracted. The very first star should have formed around 50 to 100 million years after the Big Bang. These stars could become incredibly massive, hundreds or even 1,000 times bigger than our Sun. And when these stars formed, it didn't take long, maybe 1 or 2 million years, before they disappeared. Just for comparison, our own Sun is 4.6 billion years old and still going strong. When huge stars reach the end of their lives, something incredible happens. They transform helium into carbon, then carbon into oxygen, and oxygen into a bunch of other stuff all the way up the periodic table. Then the star's core collapses, causing a massive supernova. This huge BAM releases all these heavy elements into the universe. Hooray! Now the space is filled with something new. The universe acquires many cool things, including the ingredients needed for rocky planets and organic molecules. Each generation of stars gets even richer than the previous one. Yes, to more elements. It means more rocky planets, more essential ingredients for life, and more chances for complex organic molecules to form. And now, when the universe was around 300 to 500 million years old, rocky planets were already popping up everywhere. Great. Can we have some life now? That depends on what we see as life. The recipe for life as we know it needs a special ingredient, carbon. Carbon is special because it can bond with other atoms in so many ways. It can connect with different shapes to build all sorts of amazing complex structures. It's carbon that helps us form things like DNA and proteins, which are the building blocks of living things. Now, while the universe made rocky planets relatively quickly, it took a bit longer to get enough carbon floating around. It appeared about 1 to 1.5 billion years after the Big Bang. As soon as it appeared, the universe finally had enough conditions to create life as we know it, which is why scientists are searching for planets around these oldest stars in the universe. These guys definitely had enough time for evolution. But just because you and me are made of carbon and other elements from exploded stars, doesn't mean that all life should be. Scientists are open to the idea of alternative biochemistries. There might be non-carbon-based life that we don't know about yet. For example, blobby beings made of silicon compounds. It's carbon's neighbor in the periodic table. So, when and where did life truly begin? Unfortunately, we don't know for sure yet. Most likely, the universe started preparing for life shortly after the first stars formed. And if all life is carbon-based only, then it should have appeared 1 to 1.5 billion years after the Big Bang. The universe is 13.8 billion years old. Looks like it had plenty of time to evolve lots of microorganisms. So even if we made a mistake, and the mysterious meteorite was just a piece of rock, we shouldn't give up. The search for extraterrestrial life continues, and who knows? Maybe in the future, we'll finally know the answers to all these important questions. Until then, stay tuned.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light-years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky. But its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri B, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri B had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri B receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
It's a clear night, and you're outside looking at the stars. The Milky Way alone seems overwhelmingly huge. You check on your phone and discover that the galaxy you're in at this exact moment is 100,000 light-years wide. For scale, 1 light-year is already a very long distance. For example, it takes 4.2 light-years to go from Earth to Proxima Centauri, which is the closest star to our planet other than the Sun. So, 100,000 light-years is way more than we normal humans can fathom. And that's just one galaxy. There's a whole lot more out there. Now, looking at this data, it seems pretty unlikely that we're the only life form out there, doesn't it? But how come we've never found anything else so far? Let's get one thing out of the way. Extraterrestrial life doesn't necessarily mean we're talking about little green people. It can also mean microorganisms, bacteria, and plants that can be found on other planets. The truth is, there's a big spectrum of possibilities for life on another planet. And taking into consideration that there are up to 50 billion planets in the Milky Way, it's very unlikely that we're alone in this big wide universe. And what does life on other planets look like? This is what we've spent years trying to figure out. Go ahead, think with me. A planet may be lifeless today, but it could have traces of organic matter or fossils, meaning that some life form was able to thrive there once. And it could also be that there are planets out there containing life with complex biochemistry, meaning they could have fauna just like we have on Earth, although probably not the same. NASA created a special science that is dedicated to studying life forms outside of Earth. It's called astrobiology. Ever since the space agency was created back in 1958, it didn't take long for it to start looking for extraterrestrial life. They quickly built an action plan. First, they needed to understand how life on Earth was formed, and secondly, how it could have formed on other planets. The first time NASA tried to look for life in outer space was in 1976. The Viking lander blasted into space, headed towards Mars. There were high expectations that humanity would find the first proof of extraterrestrial life. Unfortunately, the lander came back with images of a planet that looked barren and bleak, and scientists were extremely disappointed. Scientific conclusions on whether life could be detected over there were confusing. But hey, you need to know what you're looking for to find it, right? The failure of the Viking mission served to heat up debates amongst NASA scientists to define what life actually meant. And it also served to call their attention to a small but very important detail. Spacecrafts departing from Earth usually transport Earthling microorganisms and bacteria unintentionally, as they remain attached to the vehicle. It turned out that these bacteria could contaminate scientists' samples, so they needed to consider this. All of this made Mars expeditions take a back burner on NASA's short-term plans. There appeared a new priority-first question. What are the types and stages of life that space programs can hope to identify? Scientists might have encountered life on other planets, but they weren't able to identify it as life. That is why NASA began to study our own planet better. They studied everything, from ancient life forms that lived billions of years ago to living creatures that roam the planet today. They understood that the search needed to happen inwards as well as outwards. Let's take a look at the development of Earth's life from its inception. Imagine that this development can be represented as a ladder, or stairs, and each developmental stage is a flight of the bigger staircase. First, we would see basic chemistry, a soup of loose chemical elements like the ones we see in the periodic table. But they need to assemble themselves into more complex structures to be able to self-replicate, change, and evolve. This would happen in the second step, where we start to see the formation of microscopic organisms. In the third step, these cells combine to become multicellular beings, allowing for more complexity and variety. The step above sees species that can evolve big brains, enabling the use of tools, culture, and shared knowledge. That's where humanity is located. Looking at this ladder, one might ask, so what does it take for a multicellular organism to evolve into fully formed humans? This is what is called the Great Filter. It's a huge evolutionary jump that takes a lot of effort and the perfect environmental conditions for it to happen. And given that we haven't heard of any other extraterrestrial civilizations out there, it might be that we're the only ones that were able to make this jump. After all, how likely is it that we'll find life outside of Earth that is similar to us? That depends on how many planets there are out there in their star's Goldilocks zone, the area around a star where water can be liquid. And because stars come in all sizes and configurations, this zone is different for every star system. But that's not the only criteria we know for the existence of life. We usually look for three things to detect life: liquid water, methane, and oxygen. Water is what allows for chemical components to mingle and connect, forming multicellular beings. Methane is produced by the decomposition process made by bacteria, and oxygen is the byproduct of plant respiration. These are some of the telltale signs that the James Webb Telescope was programmed to search for. The James Webb Telescope has ambitious purposes that might revolutionize space science. Its top priorities are to detect forms of life by studying small galaxies orbiting the Milky Way. It will also look for the oldest stars in the universe, trying to gather data on the origin of the universe itself. That's huge! NASA is betting on two variables with this new telescope: a thorough scan on the so-called exoplanets, aka planets from outside our solar system, and the search for extremophiles, a type of life that loves extreme environments. Extremophiles were first discovered on planet Earth back in the 1960s at the bottom of the sea near the Galapagos Islands. Scientists found microorganisms living next to hydrothermal vents that dot the sea floor over that part of the world. Thriving in places like these with extreme temperatures over 700 degrees Fahrenheit takes a lot of resistance. I mean, can you imagine the heat? This discovery was a turning point for the field of astrobiology, as scientists understood that life could survive in extremely harsh conditions, similar to the atmosphere available in several exoplanets. But hey, life might turn up in our own neighborhood if we're lucky enough. Guided by the mantra, "Follow the water," NASA is launching two important missions inside our solar system that can contribute largely to the search for extraterrestrial life. You remember Jupiter, right? It's the gas giant that has a moon known as Europa. A few years ago, scientists discovered that Europa had an ocean hidden behind layers of icy crust. And there's even more. According to research, the water over in Europa is salty, much like the water we have on our planet. Europa is a big contender for the detection of life. But the Europa Clipper mission is not aimed at trying to identify this. Rather, it will orbit the moon and gather as much information about its atmospheric conditions as it can. The other moon-bound mission is the Dragonfly, an octocopter that will explore Saturn's moon, Titan. The launch is programmed for 2027 and will only arrive in Titan's orbit around 2034. It will sample and examine a series of promising sites around Saturn's icy moon. And who knows, find some new information on ET life? Let's see what happens. But I'd say we've never been closer to a huge discovery than we are now.
There are probably 36 other civilizations hanging out in the Milky Way, and over 170 billion galaxies, give or take, in the observable universe. Conditions for life are all over space. So, where is everybody? Nuclear physicist Enrico Fermi came up with this exact same question during a lunch break with his colleagues in 1950. leading to one of the most unsettling paradoxes in the universe. Even though there's a huge probability of extraterrestrial civilizations existing, we still haven't found any clear evidence of them. One possible explanation comes from the zoo hypothesis. It suggests that advanced extraterrestrial societies exist and know exactly who we are and where we are, but intentionally choose to stay hidden. They're just observing human quirky behaviors, as if we're in some kind of a cosmic wildlife park. But their intentions could be much darker. If you're a Star Trek fan, you probably remember the main rule for Federation members. Starfleet officers shouldn't contact species that are not advanced to avoid messing with their development, even if it means risking their own lives. Now, even though it's fiction, this rule perfectly captures what the zoo hypothesis is all about. Beings from other corners of the universe see our planet as a cosmic zoo with one-way bars. They can watch us brushing our teeth in the morning or walking our dog, but we can't catch a glimpse of them. In this theory, non-terrestrial life forms deliberately keep their distance from us, sticking to a hands-off policy agreement in the vast cosmic neighborhood. It's like those super smart beings agreed that we needed to have the freedom to shape our own future and destiny, following our own path of development without external contamination. The idea is that these super advanced civilizations could be like, 500 million years ahead of us, which would explain why we haven't seen any signs of them. And maybe it's better this way, as humans could eventually be destroyed or even assimilated by this new cosmic power, Independence Day style. As much as things like going to an art museum might be interesting to us, extraterrestrials probably wouldn't be too thrilled watching us stare at the Mona Lisa painting for hours. Interplanetary cultures might be more into buying tickets to quietly observe how we're developing new technologies, such as ultra-modern satellites. According to the zoo theory, they can't reach out to us until we hit a certain level of development, so improving our technology and wisdom could be the only way to show them that we're mature enough and don't need their spaceship parenting anymore. There are a couple of reasons why it's hard to buy into the zoo hypothesis. Extraterrestrials might not visit or reach out because we're not all that advanced. But it is tough to explain why they keep ignoring all our attempts to communicate, even if the zookeepers try their best not to interfere with animals' lives and behaviors. I bet they couldn't just ignore a bear speaking in loud and clear English about its desire to communicate. So that's pretty much why humans keep trying and trying to provoke some reaction from inhabitants of other planets using radio signals. In 2017, in a valley 8 miles southeast of the Norwegian city of Tromsø, a radar antenna transmitted some specially composed electronic music to potential intergalactic listeners. The target audience was in GJ273, also known as Lyton Star. It's a runty red dwarf located 12 light-years from our solar system. Since radio waves travel at the speed of light, we'll have to wait more than 2 decades before looking for a reply. But the main problem with radio waves is that we're kind of in the dark about where to look, and civilizations might be as far as 17,000 light-years away. Plus, we don't know which radio frequency extraterrestrials use to chat. Now here on Earth, we use the radio spectrum to send signals into the universe, assuming that what works for us might be a common method for other civilizations. But in fact, it could be considered a somewhat old-school technique for other beings. That's why current projects are now looking for technosignatures, which are signs of technological activity from extraterrestrials, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets orbiting nearby stars, as an advanced civilization might be altering its atmosphere with different gases, making it detectable. Despite decades of observations, there is still no definitive evidence that advanced extraterrestrial civilizations are out there. But that doesn't mean they don't exist. Even by expanding search fields, we're talking about odds much slimmer than hitting the jackpot, with a roughly 1 in 3 billion chance of finding an advanced civilization within a given distance from Earth. Maybe space creatures are responding to our communication attempts, but in a way that we can't understand. The universe has been around for more than 13 billion years, while humans showed up just 200,000 years ago. And this is about 0.01% of the universe's age. It's like we're still learning to talk, while other super smart beings might be sending us messages that are all lost in translation. We keep waiting for a giant UFO to land on Earth and for green ETs with huge eyes to come out of it. But we forget that our intergalactic neighbors could be more interesting in building nanotechnologies to watch over us. They could also be trying to communicate using neutrinos, which are subatomic particles with an extremely small mass that could effortlessly pass through our planet without being detected by our current technological devices. Now, the zoo hypothesis has another issue. It is pretty tough to believe that, with all these civilizations supposedly hanging out in the universe, they would all decide not to reach out to humans. For this to happen, there would have to be a great sense of structure, with a higher intelligence working as the head of the universe, giving them direct orders and clear rules to keep us isolated. But we're talking about billions of possibilities for life, right? More civilizations mean that there are more chances of a violation of this no-contact rule. So, most likely, at least one independent planet would be just as desperate to find life in the universe as we are. Some scientists also believe that if such advanced life had substantially colonized Earth and many other planets, we would know it by now. The zoo hypothesis has two other variations that are even more frightening. In the laboratory hypothesis, nobody contacts us because humankind is actually being subjected to experiments, and Earth is essentially a giant science lab. Otherworldly creatures could be analyzing human responses to various survival challenges, such as tsunamis or massive earthquakes. In this case, the no-contact agreement between all other space groups would make a bit more sense, since it's in the name of scientific research for the greater good, at least for them. The planetarium hypothesis, proposed in 2001, suggests that we are living in an artificial universe, in some kind of virtual reality designed to give us the illusion that the universe is empty when it's not. But no possible generator could test this hypothesis. Besides the zoo, the laboratory, and the planetarium theories, there is another possible answer to the Fermi Paradox. Nobody contacts us because humans are completely alone in the universe. This is known as the rare Earth hypothesis, and it emphasizes how Earth occupies an incredibly unique position. No other planet could bring life to the universe that could be more than just bacteria. We may consider ourselves pretty lucky, as even a small change in any of Earth's orbital parameters, like the distance from the Earth to the Sun or the rate of rotation, could make conditions too extreme for people or life in general. But again, it's hard to think that we are alone in this vast universe. So, we're back to the paradox. Where is everybody?
Your car breaks down in the middle of the highway and won't start. A friendly driver pulls over nearby and gets out some jumper cables connecting your car to his. A few sparks, and your car comes back to life. And that's how life began on Earth. Sort of. There's a theory that life was jump-started on Earth like this billions of years ago. It all started with clouds in the sky. We've all been there, sitting by the window on a rainy day. You wanted to go out and have fun, but the rain pouring outside made you want to stay in bed and snuggle. Still, the lightning and thunder are keeping you awake. With nothing better to do, you think about how lightning even forms. Like I said, clouds, and many other things. You see, when a storm occurs, cold air and warm air meet. The warm air goes up to create thunderstorm clouds, which produce droplets, and the cold air below has ice crystals in it. During a storm, the droplets and crystals have a little mosh pit and move all around. All that bumping and grinding creates electrical charges in the clouds. If you ever replaced batteries on a remote, then you've seen a plus and minus sign on either end of the battery. The plus is where the positive charge is, and the minus is home to the negative one. And just like batteries, clouds have their own plus and minus. The positive charges are kept at the top, and the minus is, you guessed it, at the bottom. So when the charge at the bottom generates enough power, the cloud lets out energy. As the energy travels through the air, it seeks out positively charged objects, like a pole or a tree. And when it finds it, the energy is released and lightning strikes. These bolts of lightning can hit anything on the ground or travel from cloud to cloud. And thunder occurs because of the hot and rapidly expanding air. So, billions of years ago, the Earth wasn't quite like today. Thunderstorms were a lot more frequent than now, and life was still in its beta phase of things. These lightning bolts may have been the key to kickstart life by producing one of the most important minerals for life, phosphorus. DNA, RNA, and cell membranes wouldn't exist without it. It's essential in all stages of our life, from growth and mobility to reproduction. Everything that makes up who we are is in our DNA, those twirly things with proteins latched onto them. So what do lightning bolts and phosphorus have to do with each other? Does phosphorus flash in the sky whenever a thunderstorm happens? Not really. When lightning strikes the ground, it creates something called fulgurites, or in English, glassy minerals fused in the heat caused by the lightning. And when they appear, they take on the shape of the lightning bolt when it strikes the ground. Some new studies suggest that fulgurites could release phosphorus when dissolved in water. When doing so, phosphorus is able to form biomolecules, which help in forming life. Back then, volcanoes were also pretty big on erupting frequently. So, with ancient hot springs, you'd expect lightning to strike down nearby and produce fulgurites next to those hot sources of water. Scientists were able to estimate that during the early days of Earth, 1 to 5 billion lightning flashes were able to occur. So, in the next billion years or so, we can expect 1 quintillion lightning strikes. Yeah, that's a lot of zeros. With all those flashes and strikes, phosphorus was able to grab its chance to start life when dissolved in water. And of course, not just phosphorus, but a mix of many chemicals and minerals were needed to perfect this recipe. Another theory on how life began on Earth starts all the way in outer space, far away from our little blue planet. Flying through the vastness of space were meteorites. Life on Earth began roughly 4 billion years ago, and these meteorites were busy flying all over the place, with many of them hitting Earth in its earliest shape. Scientists claim these meteorites carried chemicals essential to creating life. Some of those important ingredients were carbon-based compounds, including sugars and amino acids. And they needed wet and dry cycles to bond on a molecular level to finalize the process. So once life was injected into Earth, we got to see the first organisms that were around 3.7 billion years ago. Keep in mind, there wasn't much oxygen floating around or in the water compared to now. But these microscopic organisms, or microbes, left their mark with a certain carbon molecule produced by living things. But life as we know it today wouldn't happen without oxygen, that invisible element that keeps everything alive. So around 2.4 billion years ago, these microbes began changing and became Earth's first photosynthesizers. They made their lunch and dinner using water and the sun rays while releasing oxygen in the process. With many of these new organisms, the rise of oxygen made the environment harsher for microbes, but it was starting to become the baseline for life's groovy track. A new party popped out for those who could dig oxygen. You see, mammals and other organisms have multiple cell types: bone cells, skin cells, muscle cells, you name it. These microbes were single-celled organisms, so with the rise of oxygen, many of these microbes began moving in with other microbes. I don't mean being roommates in a shared apartment. They actually merged with other microbes to become multi-celled organisms. Pretty clever, huh? Fast forward a couple billion years, and we have some of our first animals to ever exist. So actually, around 800 million years ago, the oxygen levels in the ocean and seas still weren't as high as they are today. But one of the earliest creatures on Earth were sponges. Scientists were able to determine this by studying DNA on rock samples dating back to when sponges first appeared. They also claim that sponges sped up the rise of oxygen levels by eating bacteria, removing them in their decomposition phase. Then, around 580 million years ago, more creatures began to appear. The oxygen levels were starting to be acceptable for life to flourish, and many other bizarre-looking creatures inhabited the ocean floor. Even the oldest kind of jellyfish were around. They looked like tiny aliens from another planet. I wouldn't want to find any of those in my drink. And around 40 million years after the end of that period, many of these strange creatures began to disappear. It was then that scientists were able to find evidence of worm-like creatures that were able to burrow in the ocean floor. This is probably one of the first signs of evolution for survival. Then, around 530 million years ago, evolution cranked it up a notch. There were many new creatures out there with new and never-before-seen body parts. Shells and spines and other body parts allowed some of these new animals to further survive and burrow their way around the ocean floor. And shortly after, a couple of million years, the first true primitive vertebrae appeared in something that looks like an eel. This was the creature with the first backbone. Over the next million years, many of these animals began to form skeleton-based and cartilage bodies. And after much splitting, amphibians appeared, and four-legged animals began to walk the Earth's surface. It's also worth noting that there were many mass extinctions that happened along the way. But in the end, life kept evolving. And with many plants and animals emerging, the landscape was changing in the process. Many natural disasters occurred along with ice ages that froze the land and seas. To add to the overall chaos, plenty of volcanic eruptions and earthquakes continued to change the look and landscape of the Earth. The first primates emerged around 4 million years ago, and ever since then, apes and monkeys began to branch out into their own category until humans eventually came into the picture. By understanding these theories, scientists are able to observe other planets with similar conditions. We could actually witness the birth of life on another planet. Of course, this would take billions of years to happen, but I wouldn't want to miss it. Hundreds of diplomatic spaceships take off from Earth and head into space. When they reach their destination, they're met by hundreds of alien ships. This is humanity's first contact with an extraterrestrial civilization. People managed to detect them not so long ago, in a star system very close to our home. It's Proxima Centauri. This red dwarf star is the closest to our solar system. It's 7 times smaller than our Sun, which makes it only 50% bigger than Jupiter. Proxima Centauri is also 8 times as light as the Sun. This star system is 4.2 light-years away. That's how long it takes a photon of light to travel from this star to Earth. By comparison, it only takes 8 minutes for sunlight to reach our planet. If you decided to travel to Proxima Centauri, it would take you about 73,000 years to fly there in a conventional rocket. That's longer than our intelligent civilization has even existed. But it's not the star itself that interests us, it's the planet orbiting it. That's Proxima Centauri B. It's 17% bigger than Earth and about 10% heavier. It orbits its star at a distance of 4.5 million miles. By comparison, Earth is 93 million miles away from the Sun. That's 20 times farther. But the host star, Proxima Centauri, is a red dwarf. It doesn't emit as much light and heat as our Sun. So the planet Proxima Centauri B is right in the habitable zone of the star. It's located at such a perfect distance from its mother star that the planet neither gets too hot nor turns into a block of ice. In other words, the temperature there makes it possible for water to exist in its liquid state. This means that Proxima Centauri B could host life. But further observations of the planet make it doubtful. The host star is very unstable. Its brightness changes too frequently. In 2017, astronomers witnessed a catastrophic flash. The star increased its brightness by 1,000 times for 10 seconds. Before that, there was another weaker flash. The planet received an enormous amount of radiation. If there had been life there, that flare would have wiped it out completely. Overall, Proxima Centauri B receives about 400 times more X-rays than Earth. Complex living organisms cannot live under such conditions. Scientists say that even if there was an atmosphere and an ocean on Proxima Centauri B, this constant radiation would simply blow them off the planet. Proxima Centauri B is so close to its host star that it's gravitationally locked to it. This means that the planet is always turned to the star with only one side, just like the moon is turned toward Earth. That means that only one side of the planet receives this awful amount of radiation, and some experts speculate that an intelligent civilization might live on the night side of the planet. And it could be this civilization that sent us the strange signal that astronomers caught in 2019. Scientists described it as, quote, a bright, long-duration optical flare, accompanied by a series of intense, coherent radio bursts. This radio signal was observed for 30 days by one of the radio telescopes on Earth. Scientists thought the signal was artificial and could have been sent by an extraterrestrial civilization. Presumably, the signal came from Proxima Centauri B, or one of the moons that might be in that star system. But further observations failed to detect the signal. Now, the main theory claims that this radio signal is just some kind of interference from some technology on Earth. But what if it was really sent by a civilization living on the dark side of Proxima Centauri B? Well, we may soon find out for sure. People are launching a brand new telescope into space. It's the James Webb Space Telescope. It's scheduled to be launched at the end of 2021. A booster rocket will take off from Earth and reach orbit. Then, it'll deliver the telescope to a specific point between our planet and the Sun, where their gravitational forces are roughly equal. Plus, there's no light pollution in space, unlike on Earth's surface. There are also no clouds or other weather conditions that might interfere with the telescope. The James Webb Space Telescope will replace the Hubble telescope, which has been operating in space since 1990. The new telescope costs $9.8 billion. And here's why. It'll use a mirror as wide as a boxing ring. This will allow the telescope to see very far into space. So far, in fact, that the light from some events happening there won't have reached Earth yet. This means we will literally be able to look back in time. The James Webb Space Telescope will see the universe almost immediately after the Big Bang. We'll see how the first stars and galaxies were born, and how the universe turned into what we observe today. But also, this telescope can be used to examine Proxima Centauri B. Astronomers will be looking for artificial light there, like the LED lights we have on Earth. If Proxima Centauri B really hosts life on its night side, then the locals must have learned to transfer heat and light from the day side of the planet, and they would have to use artificial light to support life on their side. The James Webb Space Telescope is powerful enough to distinguish the light waves emitted by the star from those that might be created by someone on the dark side of the planet. And if we do detect some artificial light, we'll have the first ever confirmation that an intelligent civilization might exist outside our solar system. But there's always room for error in calculations and data interpretation. The only way to establish the truth once and for all is to send a space probe to Proxima Centauri. Then we can get real pictures of the planet. The main problem is distance. Although Proxima Centauri is the closest to the Earth star system, it still takes tens of thousands of years to get there. After all, the Voyager 1 space probe needed about 44 years just to leave the solar system. And that's just a small step compared to the actual distance to the nearest star. So we need other methods of travel, and they have to be much faster. Some scientists want to send microprobes to Proxima Centauri B. They won't be any heavier than a sewing needle. A launch vehicle will deploy about 1,000 of these probes into orbit. Then they will unfold a space sail. This is an ultralight material that will use the power of light to create thrust. When the sail is deployed, we'll focus a powerful laser beam onto it. This will accelerate the probes to about 20% of the speed of light. This will be an absolute speed record by our standards, but it'll still take about 21 years for these probes to reach their destination. And we'll have to wait for about 4 more years just to get the first signal from them. The Proxima Centauri star system isn't the only potential world to host life, and one of the tasks of the James Webb Space Telescope is to look out for other worlds. The telescope's powerful instruments will allow it to find relatively cold planets where temperatures are close to those on Earth. We'll be able to study in detail around 24 nearby star systems, and we'll be able to detect not only planets themselves, but also their moons. Scientists expect a boom in the discovery of exoplanets. From the start of the telescope in 2022, we'll constantly be detecting new worlds and learning more about those already discovered. The James Webb Space Telescope will allow us to better study our own solar system, Jupiter's moon Europa, for example. Scientists believe there might be water there. Although Europa looks like a block of ice, the moon's gravitational interaction with Jupiter heats its core. That likely makes the ice deep below the surface melt. So there's likely to be an ocean under the ice crust. Similar conditions could exist on Enceladus, Saturn's moon. This moon is geologically active. There are geysers that burst out of the cracks on the moon's surface. The James Webb Space Telescope's infrared instruments will be able to explore Europa and Enceladus in search of biosignatures. Those are the traces of life activity of living organisms or bacteria. This telescope is scheduled to operate for about 6 years, but in the future, we'll launch an even bigger one. It's called LUVOIR, which stands for the Large UV Optical Infrared Surveyor. Its mirror will be twice the size of that of the James Webb Space Telescope, and almost 7 times the size of the Hubble's. The telescope is scheduled to be launched in 2039. We'll get it into orbit with the help of a super heavy rocket. Then we'll have to deliver the telescope to its destination, 1 million miles away from Earth. And then it'll begin its observations. We could learn to travel faster than the speed of light by that time. Then, if we find a potentially habitable planet with the help of the telescope, we can send a space probe, or even a team of explorers there. In this case, a diplomatic meeting with an extraterrestrial civilization might become a reality.
One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler 22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler 22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler 22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler 22b snuggles up to its star a bit more closely than we do to the Sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler 22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler 22b is about 2.4 Earth's size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities. So even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler 22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler 22b is Earth-like. It could be a gas giant, or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge. Thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler 22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler 22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If there's life on this planet, it's probably quite small? Unusual plant and animal life should have adapted to the higher gravity. Trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that.
Okay, quick space riddle. Why is the search for life in the universe like a tree? Because you're always looking for a place to plant it. You know, plant it, planet. Okay, settle down. Anyway, water is the basis of life in any part of the universe, so potentially inhabited planets must have liquid water on them to support life. An incredible number of circumstances must come together for this. The planet must be in the habitable zone of the star. Then the temperature and atmospheric pressure on the planet's surface will be suitable for simple life forms to begin to evolve. A little closer to the star and the water will evaporate, leaving no chance for oceans and seas to form. This is what happened on Venus. It has a size and mass similar to the Earth, but it's too close to the Sun and no life can exist on its surface. Too far from the star, and the planet becomes too cold. Water can only exist in the form of ice on the surface, and there just might be liquid water deep below. Neptune is one example of this. In addition, the planet must be solid and have an atmosphere that protects it from solar radiation and allows living organisms to breathe. In our galaxy alone, there are countless stars. Really, you can't count on them. Near each one of them may be a planet. They're called exoplanets, and some of them may be in the habitable zone and have everything for life to form on them. From a list of 4,500 known exoplanets, scientists have identified 24 that can be superhabitable. This is the type of planet that is suitable for the existence and evolution of life, even more than the Earth. Such planets must be twice as massive as the Earth and 1.3 times larger. A bigger size means stronger gravity and a denser and warmer atmosphere. This will ensure a greater diversity of all living organisms on the planet. In addition, we should pay attention to the host star around which the superhabitable planets will orbit, and there should be a McDonald's nearby. Ideally, it should be smaller than the Sun and have a lifespan of at least 15 to 30 billion years. For comparison, the lifespan of the Sun is under 10 billion years, and it took about 4 billion for complex life forms to appear here. Stars such as the Sun can simply run out of fuel before life can develop on its exoplanet. Scientists suggest focusing on dwarf stars. They're smaller and less luminous than the Sun, but their lifespan can be between 20 and 70 billion years. This will give living organisms enough time to develop and evolve. Climatic conditions on superhabitable planets will also be different. The average temperature should be 8 degrees Fahrenheit higher than on Earth, and there should be more water in the form of clouds, liquid, and humidity. These conditions are the most favorable for biodiversity, so the whole planet would be looking like tropical forests on Earth. All 24 candidates for the title of Better Than Earth, are more than 100 light-years away from us, and with the advent of the new generation of telescopes, we'll probably be able to find out exactly if there is life there and if the conditions there are suitable for humans. Now, let's take a look at the potentially inhabited exoplanets. Teegarden B. It's an exoplanet that orbits a red dwarf star about 12 light-years away from the solar system. Typically, red dwarfs can emit flares that blow away the atmosphere of the planets in its orbit. But this host star is calm and relatively passive. Teegarden B has almost the same mass as the Earth. It makes a complete circle around its star in about 5 days. Yep, you got it right. A year on Teegarden B is less than a week on Earth. Hold on to your hats. The furthest potential inhabited planet is Kepler 1638 b. It's in the constellation Cygnus, about 3,000 light-years away from us. It belongs to the Super Earth class. It's twice as wide and 4 times as heavy as our home planet. The gravity on it will feel much stronger. Even a normal jump will be much harder for you than on Earth. Although, if this planet is really inhabited, local life is used to such conditions. LHS 1140 B. This planet is very rocky and solid. Although its size is only 40% larger than the Earth, it's 7 times as massive. It has a strong gravity of 3.25 Gs. For comparison, when you take off on an airplane, you experience an overload of about 1.5 Gs. So on this planet, you'd barely be able to stand on your feet. Because of its large mass, this planet has a thicker atmosphere, and because of the greenhouse effect, its temperature can be above 19 degrees Fahrenheit, and it rotates around its star quite quickly. It makes a full circle in just 24 days. And now, let's look at the constellation Aquarius. Here's an ultra-cold dwarf, TRAPPIST-1. A small planet orbits in its habitable zone. It's 3 times lighter than the Earth. Its temperature is similar to ours, but the gravity is half as weak. But we would still feel comfortable there. Remember the people that went to the moon? There, the gravity is only 16% of the Earth's. That's what makes the astronauts move so funny. Kepler 452b is in a system that resembles the older sister of ours. The host star is only 11% older than our Sun and is almost 2 billion years older. The exoplanet itself is 6.5 billion years old, compared to 4.5 billion of Earth's. But these sisters are very far from each other. If you travel at the speed of the New Horizons spacecraft, it will take about 26 million years to get there, so bring a big lunch. This is the closest exoplanet to us, Proxima Centauri B. It orbits the red dwarf Proxima Centauri, which is the closest star to the Sun. This planet is just 4.2 light-years away from us. Its size and mass are very similar to those of the Earth. It probably has an icy structure, like Neptune. Although Proxima Centauri is the closest star after the Sun, we can't see it with the naked eye because it's too dim. So, all these planets, including the 24 that scientists have recently found, are in the habitable zone of their host stars. And, in theory, we can colonize them and make them suitable for human life in the future. But here we'll have to solve one big problem. Even the nearest exoplanet is too far away for us today. Our modern rockets can fly at 5 times the speed of sound, and even at such speeds, it will take us more than 100,000 years to get to Proxima Centauri on one of them. Well, we need to come up with something a bit faster to travel to a new home on one of these exoplanets. And perhaps scientists already have the answer. Warp drive. Ooh. This is a piece of technology that will allow us to manipulate space and time. It creates a kind of a bubble in which the normal laws of motion don't work. So the spacecraft will be able to significantly exceed the speed of light. And this isn't science fiction. Humanity already has such technology, although just in theory yet. It's Alcubierre warp drive. And no, I didn't make that up. Since no object that has mass can travel at the speed of light, we need to do one trick. The spacecraft has to move by compressing the space in front of it and expanding it behind it. Thus, not only the ship is moving, but also the space-time inside this warp drive bubble. And the maximum speed can be 10 times that of light. But to warp the space-time, the ship must be incredibly large, and to power it, we'll need the amount of energy close to what the whole planet of Jupiter generates. Still, recent calculations of NASA's Jet Propulsion Lab show that the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round, as it was thought before. It can be more donut-shaped. Ah, donuts. This will greatly simplify the design and construction, and will make it possible to test this technology on a spacecraft the size of a Voyager 1 probe. Even though it still seems impossible, scientists are already saying that there is hope. And while we don't know what technology will be used, In 2069, NASA plans to launch its first interstellar mission to explore potentially habitable planets outside of our solar system. Various rumors say that the speed of light can be achieved with laser technology. If the probe is very small, it can be launched to the Alpha Centauri star at almost the speed of light. There are also two other alternatives to power spaceships. These are nuclear energy and energy from matter and antimatter collisions. Ooh! These technologies are still a mystery to humanity, though. Well, for the time being, stay tuned.
Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples, and this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us, or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima B is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima B at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima B has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
The dark days are mysterious natural phenomena that have occurred only a few times in the history of humankind. We can write them off as eclipses or just some weather events, but in reality, they're very creepy and we have no idea why they happen. So, what are these dark days anyway? What's so strange about them? Let's try to find out. The sun is off. What are we gonna do? That's what the residents of Yamal, Siberia asked meteorologists on September 18, 1938. In the morning, instead of going to work, they all gathered at the weather station. They were waiting for answers. All because on that day, they observed something inexplicable, an eclipse which they later nicknamed the Black Day. And neither astronomers nor meteorologists can explain what happened back then. Here's how one of them described this event. At 8:30 a.m., we noted a decrease in light. At the same time, the color of the clouds began to acquire a yellowish-brown, sometimes red-brown hue. By 9 a.m., the lighting had changed dramatically. It was as if you were looking at the world through a dark light filter. The brown tones of the clouds intensified. By 10:30 a.m., the sky and Earth didn't differ from each other in lighting and color. Everything seemed homogeneous, black, absolutely devoid of light. Pretty creepy, right? And that's not all. The city was also plunged into complete radio silence. Meteorologists couldn't even contact the authorities, and local residents were unable to set up any stations. Everyone was in the dark, both literally and figuratively. Meteorologists decided to try and launch several flares. The flares soared into the air towards the heavy dark clouds hanging over the city and disappeared. The clouds were so dense that the flares were completely invisible. At the same time, the weather was perfectly fine. Everything was quiet. And this black silence lasted for about an hour. After that, the Black Day ended as unexpectedly as it began. Even more baffling, those strange clouds left literally no trace. No rain, no dust, nothing. After that event, researchers found out that the Black Day had spread for 125 to 155 miles around. They also learned that the dark band was moving from west to east. After passing through the southern part of the Yamal Peninsula, it headed on for a while and then disappeared completely. Yamal isn't the only place where this phenomenon occurred. In fact, similar eclipses have been happening in different parts of Earth for many years. For example, in New England, on May 19, 1780, people there witnessed an event that was later called New England's Dark Day, but it lasted not one day, but several. A few days before this event, the sky turned yellow, and on May 19th, in broad daylight, it suddenly turned black. Here's what one of the witnesses, Joseph Plum Martin, later told the press. It was very dark. People had to light candles in their houses to carry on with their usual business. The night was as uncommonly dark as the day was. The smell of soot reigned in the air. Nearby rivers were covered with a thin layer of ash. When the real night came, people noticed through the clouds that the moon had turned dark red. Only a couple of days later, people were finally able to see stars through the veil of clouds. And then everything suddenly returned to normal. No one had any idea what had happened. 22 years later, on June 2, 1802, a schooner named El Dorado sailed across the Pacific Ocean. Suddenly, they were overtaken by complete darkness. There was no storm, and the ocean was completely calm, but the whole sky was covered with black clouds. These clouds dissipated after half an hour and left no trace. And again, 74 years later, one of the dark waves happened in Wisconsin on March 19, 1886. It was 3 p.m., and this time, the wave was very short. It lasted only 5 to 10 minutes. A sudden night fell on the city. Frightened horses were neighing, and terrified people were running around, trying to find a place to hide. When everything calmed down, local newspapers reported that the wave passed from west to east. There was no solar eclipse, no winds or hurricanes, nothing that could cause the darkness over the city. And finally, once again, it happened on December 2nd, 1904, in Memphis. Or rather, that's what rumors claim, since there's no scientific evidence of this event. It was clear and cold dawn over Bluff City. People were doing their usual Friday morning chores. Then, around 9 in the morning, without any warning, the sun suddenly disappeared from the sky. It took only a minute for the bright sunny day to turn into pitch darkness. People interrupted their work, and children in schools were completely terrified. And just like in previous cases, the weather was perfectly calm. It lasted for about half an hour and then suddenly ended. A little later, following a mysterious eclipse, a ferocious storm hit the city. So, what's going on? All these strange cases can surely be explained scientifically, right? Well, actually, scientists don't have a definite answer. All these events are very similar, but we don't have a single explanation that could cover them all. Let's take a look at some theories. The first thought that comes to mind, it's probably a partial or total eclipse. But no, this is not the case. There were no eclipses on those days, and even if we consider this theory, before any eclipse, the sky darkens gradually. Eclipses themselves only last a couple of minutes. Certainly not a few hours or even days. Also, unlike eclipses, these events were local to specific cities. Well, maybe it's some other astronomical event. Some scientists believe that during the event on Yamal, a band of cosmic dust touched Earth, but later they found out that no astronomical bodies approached the planet that day. Alright, any other ideas? Forest fires could be the reason. When a large area of forest is burning at the same time, a column of air can rise to great heights, like 3 to 4 miles. These airflows carry ash and other burnt stuff to different places, and since all these things are so high in the sky, they simply freeze there and turn into something resembling black clouds. That was probably the case for New England. At that time, a wave of forest fires broke out in Canada. They could easily spread through the north of the US. Also, just look at this description. Yellowed sky, the smell of soot, ash on the water. Everything sounds logical, but this theory of fires only works for the event in New England. What about the other cases? Where would you find a forest fire in the middle of the Pacific Ocean, for example? Alright, moving on. Scientists tried to explain the story from Memphis by saying it could be a hurricane, but the black cloud swept through the city before the storm, not during or after it. And it wasn't some kind of typical storm cloud, it was full-fledged night darkness. So what's really going on? Now, meteorologists call this phenomenon a local decrease in the transparency of the atmosphere. Unlike solar eclipses, this darkness is denser. It also covers only a small area. The transparency of the atmosphere is its ability to let through radiation and light. It's basically, how well can I see distant objects? Everything can get dark and blurry, for example, because of the dust in the air, volcanic eruptions, fogs, and so on. So, according to this theory, dark days are just an extreme drop in the transparency of the atmosphere. But it's still strange. If that's the case, shouldn't everything have been covered with thick fog or something like that? Yeah, it was very dark, but when people lit the lamps, the visibility was pretty good. Nothing blocked the view except the black clouds that covered the sun. In other words, this phenomenon is very hard to explain. As far as we know, it happened only 5 to 6 times in the history of humankind. If there were other cases, they weren't documented. This phenomenon is impossible to predict, and no one knows how it worked, as well as where and when it will happen next time. And although there are many hypotheses, none of them can be verified. Maybe if these events happen again in the future, we'll be able to study them better. But unfortunately, at the moment, the dark days remain a mystery. Do you have any theories or ideas on this stuff? If so, write them down in the comments.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the Kraken or Leviathan there, or weird glowing fish with two heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes. No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting, too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes.
On the moon, iron is preserved in pristine condition because there's no oxygen. It simply can't rust there. But just a couple of weeks ago, scientists made an unexpected discovery. In the higher regions of our satellite, iron is oxidized and actually rusting. At first, this finding perplexed astronomers to no end. The presence of rust might mean people can breathe, at least in certain areas of the moon. But then, the explanation surfaced. Oxygen might have got to the lifeless rock from our own planet. In the absence of atmosphere, solar winds beat the moon relentlessly, and nothing can stop them. These flares could swoop some oxygen from the upper layers of the Earth's atmosphere and carry it all the way to the moon. The molecules then come to rest at the highest points of the moon's surface. That would explain why metals don't get oxidized in the ravines, and especially under the surface of the satellite. While we're on this topic, the moon has long been believed to have formed as a result of a humongous impact with the Earth. A Mars-sized celestial body could have driven itself into our planet and made part of its crust shatter. The resulting debris then packed together in a tight ball, which later became our moon. But there's one question that's been bugging scientists. The Earth's crust is poor in metals. So how come the moon has so much metal within it? The latest research basically throws the main theory out the window. So in 2020, we again know nothing about our closest neighbors coming to existence. There's news from the further reaches of outer space, however. Astronomers from MIT registered a repeating signal from 500 million light-years away. Such signals are called fast radio bursts, or FRBs, and they're usually singular events. No one knows what their sources are, but they could be supernovae, or bursts of energy from quasars. This repeating one, though, is pretty creepy, because it's regular. For 4 days, radio equipment captures signals all the time, and then they abruptly stop. But after 12 days, the same pattern begins. 4 days of constant radio bursts, and 12 more days of silence. Astronomers managed to locate the signal as coming from a galaxy 500 million light-years away from us. But what causes it is still unknown. It may be a spinning quasar or a supermassive black hole, but an alien technology is not excluded either. Speaking of which, there just might be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of a comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures. Microbes, at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only inhabitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of sun-like stars and Earth-like planets, and some of them are surely more like ours than others. One such planet can be closer than you think. Venus, the Earth's evil sister, might be home to microscopic life. Even though its surface is as hot as a furnace and showered by acid rains from carbon dioxide clouds, there might be something alive in its atmosphere. Scientists have recently picked up traces of a gas called phosphine that can be produced by microorganisms. In very small amounts, it could appear by non-organic means, but telescopes have found much more of this gas. This discovery came as a huge surprise because Venus was believed to be too hostile for any forms of life. Now though, it might become the first ever planet, apart from Earth, to be home to living creatures. The microbes that produce phosphine probably live in the acidic clouds, and they don't need oxygen to survive. Another promising world has been suddenly found while rummaging through old space telescope data. In 2018, astronomers analyzed information received from the Kepler telescope and, as usual, disregarded pieces they didn't think were relevant. But 2 years later, while going through this old data, scientists noticed that one object was misidentified. It turned out to be an exoplanet 300 light-years away from Earth, and so much similar to it that it was almost a doppelganger to our home. Kepler 1649c is only 6% larger than Earth, and probably consists of the same minerals. It also receives about as much light and energy from its star as we receive from the Sun. The only problem for now is that the star could flare up too often, making the surface of the planet too hot and scorching its atmosphere. Still, there's no proof of it yet, and we could have a potentially habitable planet pretty close to home. AU Microscopii, or AU Mike for short, is basically a cradle of a new star system that can be observed directly. It's really close, only 32 light-years away, and the star is very young, around 150 times younger than our Sun. On a cosmic scale, it's like a newborn baby, and you can still see a cloud of debris swirling around it from the time it was born. But the curiosities don't stop there. NASA added a poster featuring AU Mike to its Galaxy of Horrors series because of the planet that orbits the star. AU Mike B is so close to its Sun that it makes a full circle around it in just 8.5 days. Being so young, the star frequently throws tantrums, resulting in horrible doses of solar radiation storming the poor planet. As you may guess, no life is possible in such conditions. Still, the scientists are happy to have found this system because it sheds light on how stars and stellar systems are formed. Back to Earth now. The climate changes we're witnessing are most probably part of a natural cycle. Researchers from the University of California, Santa Cruz have devised a pattern in our planet's climate variations, and they look like extremely long seasons. Sometimes, these states could last for millions of years, and they're all related to how the Earth is positioned relative to the Sun. The seasons were dubbed Ice House, Cool House, Warm House, and Hot House, according to the prevalent temperatures. For the past 3 million years, for example, our planet has been in the state of Ice House since the last ice age was not so long ago. But humanity's actions, adding to the greenhouse effect, have pushed the climate state to Warm House much faster than it would have come without us. When it finally comes, the overall temperature on Earth will rise to tropical values, something that the planet hasn't seen in over 50 million years. What a time to be alive. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance, thanks to which we can now thrive. But there's now a new advance which suggests another scenario. In space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth, not only thanks to fossilized remains of living beings, but from outer space as well. Remember the huge asteroid that led to the extinction of the dinosaurs? Well, I wasn't around then, but scientists say it could be caused by something entirely different. At least one mass extinction was probably a result of a supernova explosion far, far away from our planet. A starburst as powerful as you can imagine lit the Earth brighter than the sun one day, and soon its UV and cosmic rays reached the ozone layer of our planet. As they did, the planet's protective cover was burnt away, and everything that was below suffered the consequences. It took the Earth hundreds of thousands of years to recover from that onslaught, and if it happens again, which it might, we won't be able to survive. Luckily, the closest event like this is the explosion of Betelgeuse, and that star is way too far from us to do any serious harm.